Okay, in this video we're just going to have a quick look at what turning and stationary points are. So if I have a curve like this, where we've got the gradient going up, increasing, then, the gradient flattening off, then getting to position where it's zero, or what we call stationary or turning, and then steepening up again, but it's getting negative, then flattening off again, and then getting steeper again. These 2 points here, so this one here, and this point here, what we call stationary points. You can see the tangents are flat. So therefore, at these points, dy by dx will equal 0. Yeah, if you draw a tangent here, we can see the gradient is going to be positive. If you draw a tangent here, you can see the gradient is going to be positive. And you draw a gradient in between them, you're going to get a gradient negative. So we've got 2 types of stationary points here. We've got where the gradient goes from positive to 0 to negative is a maximum. And where the gradient goes from negative to 0 to positive, you've got a minimum. Then there's a special kind where the graph does this, then it flattens off, then it increases, or goes down, flattens off. Whether this graph flattens off like this and keeps increasing or decreasing, they're called points of inflection. Alright, but still this rule of dy by dx equals 0 holds true. So let's look at some examples. So let's have a look at an example of stationary points question. So we're going to find the stationary points of y equals x cubed minus 9x. First thing we need to do is find dy by dx. And that equals 3x squared minus 9. Times by the power, take 1 off the power. Remember, 1 off this means u2x to the naught. Then we're going to let dy by dx equals 0. So this would imply 3x squared minus 9 equals 0. So 3x squared will equal 9. So therefore x squared will equal 3. So x will equal plus or minus the square root of 3. Square root of 3 gives you root 3. But remember, if you square a negative number, you get a positive value. So if we square minus root 3 times minus root 3 will give us 3. So therefore we have a plus or minus root 3. Now what we need to do is decide what type of turning point we have. So let's do a little table of values. So we're going to have x. And we're going to have x less than minus root 3. X equals minus root 3. Minus root 3 is less than x is less than root 3. X equals root 3, and x is bigger than root 3. Well, at these 2 points, we know that dy by dx equals 0. That's the whole point. So what we're going to do is work out what happens when we're less than minus root 3. So what's less than minus root 3? Well, minus 2 is. So if we were to look at dy by dx when we put minus 2 in, minus 2 squared is 4, times 3 gives you 12, take away 9 gives you a positive value. And when we're between these 2 values, well, naught is between these 2 values, put naught into this and you get a negative value, not minus 9. And then if we go to greater than root 3, so let's pick, I say 2, 2 squared is 4, 12 minus 9 also gives you a positive value. So what's happening? We've got positive, 0, negative, 0, positive. So here we have a max, and here we have a min. Okay, and that's our answer. So we have at x is equal to plus root 3, so x equals root 3 gives us a max, and x equals minus root 3 gives us a min. Sorry, wrong way around. Plus root 3 is a min up here, and minus root 3 gives us a max. Okay, let's have a look at a different example. Let's look at y equals x cubed plus x squared plus x. So let's differentiate this and see where the turning points lie. So dy by dx equals 3x squared plus 2x plus 1. Now, we want to solve dy by dx equals 0. So therefore 3x squared plus 2x plus 1 equals 0. I can't see immediately how to factorise this, so I'm going to use the quadratic formula. So x equals minus b, so it's minus 2, plus or minus the square root of b squared, so that's 2 squared, minus 4 times a times c. Sorry, a is 3 times c is 1. All over 2 times a. Now straight away you'll see this part of the expression here is negative. 2 squared is 4. 4 times 3 is 12, times 1 is 12. You've got 4 minus 12, so you've got underneath here, okay, you've got the square root of minus 8. Now this can't happen. So what does this mean? This means we have no turning points. So this cubic graph won't have any stationary points. It's just going to go from here to here and up here. It's just going to go from low to high. And we can see that it's probably therefore only going to cross at one point. If you factorise this out, okay, this bit can't be factorised and it can't be solved. If you look at it, b squared minus 4ac is going to give us, b squared is going to be 1, minus 4ac is 4, so it's going to give us a minus root 3, so that's not going to have any solutions. So the only solution to this graph is going to be, at 0. Okay, it's going to cross the x-axis at 0, and it's just going to be increasing all the time. I don't know where this inflection will come. This is beyond the scope of C1 to be able to do, and we'll look at that in due course, where this part of the graph comes, where this actual sort of change from going to flat to going to steeper there is, doesn't ever make it to 0. Now let's look at one where we do have a 0 stationary point. Well, it's a nice easy one. Let's look at y equals x cubed. dy by dx equals 3x squared. Now if we make that equal to 0, you get 3x squared equals 0. So therefore x squared will equal 0. So therefore x equals 0. And then let's look at what happens here. So let's do our table of values again to determine the nature of our turning point. So we want to look at x is less than 0, x equals 0, and x is greater than 0. So always put the turning point in the middle. We know this is 0. We know dy by dx. So whenever you do these tables, you put the turning point in the middle and look to the left of the turning point and to the right of the turning point and look at what happens to the differential. So less than 0, let's pick a value, minus 1. If you put minus 1 squared into this, you get a positive value. If you put a bigger naught, 1 into this, you also get a positive value. And everything, this is always going to be positive because the least it can be is 0. Because x squared is always positive. So we've gone from positive to 0 to positive. So we have a point of inflection. At x equals 0. So here we go. We have 3 types of questions. On this one, we had a maximum followed by a minimum. So the graph was doing this shape. So max followed by min. Notice again, I put where the 0 was in the middle of my table and worked out what was happening either side. Put what the value was here in the middle, worked out what was happening either side, and then I was able to look at the shape of my graph. Positive gradient, 0 gradient, negative gradient gives a max, negative gradient, 0 gradient, positive gradient gives a min. Then on this question, we didn't have any stationary points. There was no solutions when dy by dx equals 0. Okay, so no stationary points. And finally, on this question, we had just a point of inflection. So when we put the values in, we went from positive to 0 to positive, so therefore we have a point of inflection.